Hello everyone, my name is Maximilian Hing, and today I'm going to be presenting the second lecture on Introduction to Calculus. Today this topic will be advanced derivatives. So last time I gave you a couple differentiation formulas, as you can see here, to differentiate functions. However, these formulas can only be used for relatively simple functions, not for more complex functions. So today I'm going to be giving you some other differentiation formulas for more complex functions. So first, let's focus on the trig differentiation formulas for the six fundamental trigonometric functions. Our first three derivatives are as follows, as shown. The derivative of sine of x equals cosine of x. The derivative of cosine of x equals negative sine of x. And the derivative of tangent of x equals secant squared of x, where secant squared of x equals 1 over cosine squared of x. So now, for example, if we want to differentiate this function, f of x equals 2 cosine of x, we would simply use this rule here. And from last lecture, we can see that we can use a constant multiple rule to factor the 2 out of the differential. And then we would get negative 2 sine of x. For our next three formulas, we have the derivative of cosecant of x equals negative cosecant of x times cotangent of x. The derivative of secant of x equals secant of x times tangent of x. And the derivative of cotangent of x equals negative cosecant squared of x. So now, from these rules, we can see if we have a function f of x equals 6 secant of x, we can just use this rule here and factor out the 6 from the differential. And once we differentiate, we would get 6 times secant of x times tangent of x. There are some basic problems to get you familiarized with differentiating trig functions. Okay guys, let's go through with the first question of the practice set. We have f of x equals sine of x. So now, if you remember from our 6 basic differentiation rules for trigonometric functions, we have the derivative of sine of x equals cosine of x. So since this is just sine of x, you would then get that the derivative is just equal to cosine of x. Okay, let's go through the second question now. We're given g of x equals 5 times the cosine of x. Now, using the second rule from our trig differentiation rules, we have this. This is our second rule. So now we see we have a cosine of x here multiplied by a constant. We just take the constant out and we get now differentiating, we get the derivative of g of x equals to negative 5 times sine of x. Okay, now let's go through the third question. We're given the function h of x equals to 3 sine of x minus 4 cosine of x. So now let's break this down step by step. We're given two trigs, sine of x and cosine of x. Now, let's recall that the derivative of sine of x equals cosine of x. And the derivative of cosine of x equals negative sine of x. Now we also can see that we have two constants. We can just ignore the constants for now and differentiate the trig functions. And that, once we put everything together, will leave us with the derivative of h of x equals to 3 cosine of x plus 4 sine of x. Okay, now let's go through the fourth question. We're given k of x equals to 2 secant of x plus 7 cosecant of x. Let's remember the derivative rules for each of those. For secant of x, we have the derivative of secant of x equals to secant of x times tangent of x. Now, the derivative of cosecant of x equals negative cosecant of x cotangent of x. Now, we can also see that we have two constants, so we just ignore them for now. And we will just take the derivative of the trig expressions. So from that, we would get the derivative of k of x equals to 2 secant of x tangent of x minus 7 cosecant of x cotangent of x. Okay, now let's look at the fifth and final question of this practice set. We're given m of x equals 4 tangent of x minus 6 cotangent of x plus secant of x. Now let's break this down. First, we need to find the derivative of tangent of x. So the derivative of tangent of x equals secant squared of x. Now the derivative of cotangent of x is equal to negative cosecant squared of x. Finally, the derivative of secant of x is equal to secant of x tangent of x. Now we can also see we have some constants. We can ignore these for now and just take the derivative of the tangent, cotangent and secant. So putting everything back together, we would get the derivative of m of x equals to 4 secant squared of x plus 6 cosecant squared of x plus secant of x times tangent of x. Here's an example of the usage of the product rule. So we have f of x equals to x squared times natural log of x. And to make it easier, I've listed the functions f of x and g of x and their derivatives. So if we use the product rule, we get x squared, the derivative of x squared times natural log of x plus x squared times the derivative of natural log of x. So using the rules over here, we get f prime of x equals to 2x times natural log of x plus 2x times 1 over x, as shown here. Then we get f prime of x equals to 2x natural log of x plus x, since we can cancel these two out. So our final answer would be f prime of x equals to x times 2 natural log of x plus 1 once we factor out the x. Here's an example of the usage of the product rule. So we have f of x equals to x squared times natural log of x. And to make it easier, I've listed the functions f of x and g of x and their derivatives. So if we use the product rule, we get x squared, the derivative of x squared times natural log of x plus x squared times the derivative of natural log of x. So using the rules over here, we get f prime of x equals to 2x times natural log of x plus 2x times 1 over x, as shown here. Then we get f prime of x equals to 2x natural log of x plus x, since we can cancel these two out. So our final answer would be f prime of x equals to x times 2 natural log of x plus 1 once we factor out the x. Lastly, we will be covering the chain rule. The chain rule allows us to find the derivative of a function expressed in the form of f of x of g of x, otherwise known as the composition of functions. The chain rule formula is the derivative of f of g of x equals to f prime of g of x times g prime of x, where f of x is the outer function and g of x is the inner function. So this is how we would use the chain rule. Let's say we have f of x equals 6x squared plus 7x to the 4th power. So now we can, if we use a bit of logic, we can see that the outer function would be x to the 4th, and the inner function would be 6x squared plus 7x. So using the chain rule, we take the derivative of this part and put it outside. And we take the derivative of this x to the 4th with respect to this. So we get 4 times 6x squared plus 7x times to the 3rd power times this. So that would basically be our answer. Another example of the chain rule would be the function g of x equals to e to the 1 minus cosine of x power. So we have an outer function of e to the x, and we have an inner function of 1 minus cosine of x, since it's replacing the x of the e of x function. Using the chain rule, we will take the derivative of this inner function, which would be sine of x, by the trig differentiation formulas. We put this out front and multiply by the derivative of this function with respect to this. And since e of x is always the derivative of e of x is always equal to e of x, this function remains unchanged. We just get the derivative of g of x equals sine of x times e to the 1 minus cosine of x power. Okay, so here are some practice problems involving product rule, quotient rule, and chain rule. I have listed all of these formulas over here. Okay, let's have a look at the first question. We are given y equals to 1 plus the square root of x cubed times x to the negative 3rd minus 2 times the cube root of x. And we're asked to find the derivative. So let's break this down. We're given the product of two functions, which immediately indicates that we need the product rule. So if we re-express these two, we have x to the 3/2 power and 2 times x to the 1/3 power. So now it's clear that we can just use the product rule to find the derivative of each of the two expressions. So now, using the product rule, we take the derivative of this one and multiply by the original term for here. Okay, now we'll take the derivative of the second term multiplied by the original first term. Now, this would be our expression. If you wish to simplify, then go ahead. But I will not be simplifying this for the sake of simplicity. So this would be our answer. Okay, now let's go through the second question. We're given the function r of w equals to 3w plus w to the 4th power over 2w squared plus 1. Now, we see that we have a fraction with two functions, in the numerator and the denominator. This immediately tells us that we have to use the quotient rule. So, using the quotient rule, we first take the derivative of the top term divided by the original second term. And then we take the derivative of the second term times the original first term. But we can't forget that we have a minus instead of a plus. And then we take everything divided by the square of the second term. So now, if we try simplifying a bit, we will get the derivative of r of w equals to 4 times w to the 5th power plus 4 times w to the 3rd power minus 6w squared plus 3 over 2w squared plus 1. I'm sorry guys, I forgot to put a square over here. Okay, now let's go through the third question. We're given d of t equals to 6 times the cube root of t over 4t plus 1. Now we also see we have a fraction with a function in the top and a function in the bottom. This should tell us that we need the quotient rule. Let's re-express the top term here. This equals 6 times t to the 1/3 power. Now we can use the quotient rule with the power rule. So we take the derivative of the top term times the original bottom term. Minus the derivative of the bottom term times the top term. Over the square of the bottom term. So now we can stop here actually, but I'm just going to simplify this quickly. Okay, now let's look at the fourth question. F of t equals to function e to the negative 6t plus sine of 2 minus t, everything to the 3rd power. Now, since we have a function here, inside this function xq, we can see that we need a chain rule. And here's the tricky part. We actually have two additional chain rules here, since we have negative 6t inside the e to the t, and then 2 minus t inside the sine of t. So let's break this down. First, we're going to do the chain rule on this entire expression. So we'll get I'm going to write out the expression, derivative of this expression with respect to the inside. But now, if we want to take the expression of the derivative of the inside, we now have to do the chain rule again. So let's do this expression. So since we have an inside of negative 6t, we take the derivative of that and we get negative 6. The derivative of e to the t is just e to the t. So now we substitute everything from the original expression into the chain rule, and we would get negative 6 times e to the negative 6t. Now, we're going to look at this part. We have an inner expression of negative 2t and an outer expression of sine of t. We take the derivative of this one, we get negative 1, and the derivative of this one would be cosine of t by the trig differentiation rules. So now once we input everything into the chain rule, we would get negative cosine of 2 minus t. Now plugging everything back into the original expression, we get this times negative 6 e to the negative 6t minus cosine of 2 minus t. And that will be our answer. Okay, let's look through the final question. We're given v of x equals to natural log of sine of x minus cotangent of x. So we have a common function here and an outer function here. So we have to use the chain rule. Now, recall that the derivative of natural log of x equals to 1 over x. Then, taking the derivative of this whole expression with respect to the inside expression, we get 1 over sine of x minus cotangent of x. Now we have to multiply by some expression, which is the derivative of this expression here. So now recalling that the derivative of sine of x equals to cosine of x, and the derivative of cotangent of x is negative cosecant of x. We just multiply this expression by the fraction, and we would get this. Now I have some bonus questions for you involving all the material covered today. However, I will not be explaining all of the questions, but the rest will be in the link in the description. Okay, I'm going to be going through questions 1, 3, and 6. First, let's look at question 1. We're given f of x equals to sine to the 4th of x. Now, this may not be immediately obvious, but we have an inner function of sine of x and an outer function of x to the 4th, since we can re-express this as sine of x to the 4th. So let's use a chain rule. First, we can recognize that the derivative of sine of x is equal to cosine of x. So we break that out front. Next, now we'll take the derivative of the outer expression with respect to the inner expression. So if we simplify, we get the derivative of the function equals to 4 cosine of x times sine cube of x. Okay, now let's look at question 3. We're given f of x equals to x times the tangent cube of x. Let's re-express this as x times tangent of x cubed. Now, this is a bit tricky since we have a product of two functions, but we also have a chain rule here. So let's take the derivative of this systematically. First, we see that we have the product rule out front, so let's do the product rule first. Take the derivative of this expression here, x, which is just equal to 1, so we get tangent cube x plus x times whatever the derivative of this expression is. So now let's do the chain rule. We take the derivative of the outside with respect to the inside, so we get but now, we also have to take the derivative of the inside. And now we also know that the derivative of tangent of x is equal to secant squared of x. So, our simplified expression would be f prime of x equals to tangent cube x plus 3x tangent square x secant square x. Okay, let's look at question number 6, which will be the final question I'm covering. We're given f of x equals to tangent of x over 1 plus x squared. So this is a little trickier than the other questions because not only do we have the quotient rule, we also have a chain rule. Let's do this step by step. First, let's do the chain rule. The quotient rule. We'll take the derivative of the top. And multiply by the original term from the bottom. Now, we want to take the derivative of this term times this term. But we still need to do the chain rule on this one to find the term. I'm going to label this term as y for now. And then, of course, we divide by the square of the bottom term. So now let's use the chain rule on this term. We have an inner function of 1 plus x squared and an outer function of x squared. So our chain rule states that the derivative of the inside is 2x. And then we take the derivative of the outside with respect to the inside, which gives us 2 times 1 plus x squared, which equals 4x plus 4x cubed. So, now we can just substitute this into y. And then we get f prime of x equals to secant square of x times 1 plus x squared minus four x plus 4x cubed times tangent of x divided by 1 plus x squared to the 4th power. And that would be our final answer. Remember, if you want to view the solutions to any of the remaining problems, visit the link in the description.